In this video, you are going to learn about enthalpy, particularly enthalpy of formation. Before we get into detail, I would like to talk about standard state. Standard state is usually when people publish about data and is tabulated in certain conditions. For example, as for reactions, most of the data is published in standard state. That means it is about room temperature, which is about 25 degrees Celsius. That is about 298 Kelvin, and also at 1 atmosphere, ATM. Sometimes we call that ambient condition. Now, let's talk about standard enthalpy of formation, or let's just call it enthalpy of formation for now. Let's look at the definition. It is an enthalpy change for a reaction in which exactly 1 mole of a pure substance is formed from its constituent free elements in their most stable state under standard state conditions. Wow, the definition is long. Let's look at it. It says exactly 1 mole. That means in the reaction over here, we should expect the coefficient of the product is 1. So the first requirement will be coefficient of product is 1. Okay, let's look at the next one. Of a pure substance. That means in the product, we are only allowed to have 1 product. For example, if anything like this, let's say CH4, there's a combustion of methane that can give me carbon dioxide and H2O. In this case, we cannot call the enthalpy for this reaction is a enthalpy of formation, because in the product we have 2 products instead of a pure substance. So the second requirement is 1 product on the right side. Okay, let's look at the other one. From its constituent free elements. Okay, that means each reactant is in their elemental form. Okay, so reactant must be in elemental form. Let's look at this. This one, carbon, yes, elemental form. Oxygen, yes. In the example that I gave earlier, oxygen, yes, it is. But methane is not. Why? Because it's a combination of more than 1 element. Okay, so let's continue. And their most stable state, what do I mean by that? That means oxygen at room temperature and 1 atmosphere, it should be O2 gas. Okay, so if you see something like O3, it's not the most stable state. Or if you see O2 solid, in room temperature and at 1 atmosphere, oxygen should be a gas. All right, and most stable state, okay, so it must be satisfied all these conditions. Okay, the first one will be in the product, we should expect to have the coefficient 1, and there should be only 1 product. All right, and the reactant must be elemental form and also most stable state. Okay, so by definition, the standard enthalpy of formation of an element in its most stable form is equal to 0. Why? Because in order to have enthalpy of formation, let's say if I want O2 gas, how do I make it from elemental state? It must be only from O2 gas. That's why it should be 0. All right, let's do some exercise. Number 9. I'm working on number 9 now. For which one of the following reaction is the delta H of the reaction, or enthalpy of the reaction, is equal to the heat of formation of the product? Okay, we just went over all those 4 conditions. Okay, so the first condition is, we are going to write that down, coefficient should be equal to 1 in the product, equal to 1. Let's check. This one is 2, and therefore enthalpy of reaction would not be equal to enthalpy of formation. This one is 1, so it may be good. This one is 1, it may be good. This one is 1, it may be good. Okay, what is the second requirement? So it must be just one product on the right side. Okay, let's check. This is good, this is good, this is good. Third one, the reactants must be in its elemental form. Let's check. Over here, it's good, it's good. Over here, it's good, it's good. Elemental form. Okay, they all look good so far. Number 4, the most stable state. Okay, that means under ambient condition at room temperature, what would be the right state? Let's look at it. This one, nitrogen is a gas, that's good. Oxygen is a gas, that's good. So this one is really good. Look at this one. Carbon is a solid. Well, carbon standard state. It is graphite, it is solid. Look at this one. Hydrogen. Hydrogen, the most stable state at room temperature will be hydrogen gas. So this one is not good. All right, let's look at this one. Hydrogen, the same reason. It's not gas, so it should be the most stable state. All right, so we know that B is the right answer. Okay, let's do another exercise. Number 10, of the following, which one, the delta H formation, the enthalpy of formation is not 0? Under what condition is 0? Under when it is in its elemental state, elemental, okay, elemental, and also most stable state, then it will be 0. Okay, let's look at this. This one will be 0. Carbon is a solid graphite, that is 0. Nitrogen, gas, that is 0, that's good. How about this one? Fluorine. Fluorine is a gas. Okay, so solid is not 0. If it says fluorine to gas, then it will be 0. Okay, let's look at the other one. Let's do more exercise. Number 12. For which one of the following equations is enthalpy of the reaction equal to enthalpy of formation? Okay, requirement number 1, the coefficient of the product should be equal to 1. Let's check. This is good. Coefficient 1, coefficient 2, no good, because we don't need coefficient 2. And by the way, the second one will be just single or just one product. That's the second requirement. And this one has 2 different products, so we know that it's not good. Okay, over here, coefficient is 1, so potentially this one is the right answer. Coefficient is 2. Okay, so the second requirement is just one product. So the rest of this will be one product, except B. B has 2 different products. The third requirement, elemental form in the reactant. Okay, so reactant must be elemental form. Let's look at this one. Elemental, that's good. Elemental, that is good. Let's look at this one. Not elemental form, because this reactant over here is a combination of 2 different elements. So this is not good. Let's look at this one. Elemental form is good. Elemental form is good. So this one is good. Elemental form, oxygen, that is good. Carbon monoxide, no, it's not elemental form because it has carbon and oxygen. So this is not good. Number 4, the reactants in its most stable state. Let's check. Okay, these are gas, that's good. So A is good. Let's check this one, C. N2 is good. Okay, oxygen, most stable state is O2 gas. It's not O3. O3 is ozone, itself is not stable. Okay, so we know the answer. Let's do more exercise. For which one of the following reactions is the value of enthalpy of reaction equal to enthalpy of formation? Well, we follow the same rules. Coefficient is 1 for the product. Okay, so this one is not good, this one is not good. Okay, it can be none of, it may be this one, let's check. One product, there's only one product that is good. Reactant is in its elemental form. This one is not elemental form, it has 2 different elements. So the answer is D.